we're focusing just on, this topic was originally about authenticating users, but we're focusing just on passwords. So let's go through and just skip through some slides that we've already seen in detail and return to the ones we've missed. So we know that we want to authenticate a user. We use an ID to identify them, like a username, and we use some other information for the verification to check they are that right user. Password is what we're going to focus on. But there are other things than passwords. PIN, a passphrase, we can think the same concept as a password, but there are other things we possess, tokens, and then biometrics, things we are and things we do, but we're not focusing on them. Just be aware that it's not just passwords that we use for authentication. So the basic way to use passwords is that for the system that you want access to, you register a username and password, and then when you want to access that system, you supply a username and password, and the system compares the supplied values with the registered values. If they match, everything's okay and you get access. That's the basic approach. So we've mentioned this before, and there are many issues involved with how does that work securely. And we've looked at a few of them. A few slides here that we've skipped over, so let's go through them now. So what's the problem with passwords? And we may have talked about some of these, but let's go through some different names. An offline attack. Offline means that the attacker is not trying to access the system to get access. They've somehow managed to get some information about passwords and trying to guess your password. So let's say the system that we're protecting is the Moodle website that you log in for the quizzes. So that system has the list of usernames and passwords. An offline attack would be some attacker has somehow managed to gain the list of passwords, or what we know from last lecture, hashed and salted passwords, and then they get that list and they take that back to their house and on their computer, and from that they try and do a brute force attack to guess your password. So in an offline attack, the attacker is not submitting attempts to the system. They're doing the attack in their own time and with their own resources. An online attack is when, let's say we have the Moodle website, an online attack would be that someone submits a username and password trying to guess your password, and the system would return an error or success. Offline is that they're trying to guess your password using other measures outside the system. And the last topic we looked at how to store passwords, and we'll summarise that later, but we saw that we don't store the password in the database. We should store a hash of the password so that if someone does discover the database, they can't get the original password. And even better, store the hash of the password combined with some random value, a salt. Okay. So, offline dictionary attack. The attacker gets this database of hashed passwords. So what they do is they take those hash values and try and work backwards to find the correct password of the users. And we gave a few examples of how they could do that. A brute force approach is try every possible value. A dictionary attack is try values which are most likely. Of the 40 users in this class that have access on Moodle, I suspect some of them may have passwords which are much more likely to occur than others, like from common words from a dictionary. Therefore, the attacker would try those first, rather than trying random passwords. So there's an offline dictionary attack. How do you stop it? Control access to the database. Try and set up your system so that a malicious user cannot access this list of hash values, the database of password information. Reissue passwords if they're compromised. Let's say I run the Moodle website and I realise someone has accessed the database due to some other flaw. Then immediately I should tell all the students, your password has been cancelled, you need to set up a new one through other means. so that even if the attacker finds your password, they will not be able to access the system. So stop using the passwords once you know that they're compromised. And what we got to in the last lecture is store the passwords such that even if the database is accessed, it takes a lot of effort for the attacker to take that hash value and get the original password. So use good hashing algorithms and use salts, that is these random values, to make it harder against rainbow attacks. So offline, the attacker gets access to some password information and then tries to guess in their own time. Let's look at a few other attacks, and I think most of them, not all, are online attacks. A specific account attack. The attacker submits guesses to the system for a specific account. You're the attacker. You want to log into Moodle as me. You know my username, so what you do is you go to the website, you type in my username and guess a password. The system returns an error saying no, incorrect, so you try again. And you keep trying until you get until you get my password. So you're attacking a specific account. One way to stop that is once there's been a certain number of attempts, failed attempts on that specific account, don't let any more attempts to take place. Lock the account. Okay? And I think you know that with, if you've had the bad luck, if you forgot your PIN for your ATM card. You go to the ATM and you type in your PIN. If you get it wrong, 3 times, your card gets eaten by the ATM. It doesn't come back. So you can no longer make attempts. So that's a simple example of locking the number of attempts after too many failed attempts. Any other ideas how to stop a specific account attack? You want to stop them. What else can you do? All right, that's that one. Disable the account if there are too many attempts. Okay. What's the problem with that? What's the problem with the countermeasure? Sorry? All right, if I forget the password myself and I'd make, let's say I'm limited to 3 attempts and I make 3 attempts, or I hit the wrong key when I type it in, then I've locked myself out. So that's an inconvenience. Yep.
You need to find a secure way of unlocking it.
Okay, so that leads to, once the account is locked, how do you deal with that? So if I lock myself out because I typed the password or forget it, then I need some other way to securely make sure I can get the correct password. What happens with the bank? Anyone done it? Type the PIN wrong 3 times in the ATM? Yeah, I've done it. Your ATM's stuck in there, okay? So you need to go to the bank, the actual branch, and provide some identity and then go through some steps to prove you are the right person, and they'll set up a new PIN, okay? But that takes time, it's an inconvenience, and it's something you cannot do online, okay? So there may be other ways, but it's very inconvenient once the account is locked. What's the other problem with this countermeasure? Think you're an attacker. How can you take advantage of this? You want to, let's say there's a quiz, the deadline is in 10 minutes, and you know that some student in the class, if they do it, they're going to get a higher score than you. So what you do is you go and try and log in as in their account 10 times until the account's locked, and that means they can't do the quiz because they can't log in. You've denied them access to the system, meaning they have lost something there. Okay, so it's called a denial of service attack. You, or the attacker, forces the account to be locked, locking it for the normal user so the normal user cannot access their account. So very inconvenient because now the normal user has to go and manually get it enabled. So although the countermeasure works, it can also be easily used as some form of denial of service by the attacker. get the account to be locked so that the normal users can't use it. Another one, popular password attack. Let's say a popular password is, remember any from the last slides? What's a popular password? 1, 2, 3, 4, okay? Let's say of the hundreds of students at SIT, it's likely that someone has chosen 1, 2, 3, 4 or similar. So what the attacker does is for the first student ID, they try and log in as 1, 2, 3, 4. If it doesn't work, they try the next student ID and log in using the popular password 1, 2, 3, 4. And they keep going, trying all the different students, and it's likely after they've tried all the students that at least one of them had that password and they get access. So it's not accessing a specific account, it's trying to access any account and using popular passwords, not just one, you can try a range of popular passwords. Locking the account doesn't help because you only make 1 or 2 attempts on that one user's account. Locking the account is only really useful if it's multiple attempts on one user's account. But the popular password attack, try each user once so their account won't be locked. How do we fix that, or how do we make it harder? Make sure that the users select good passwords. They don't select popular passwords. So when the user registers their password, that they don't have the opportunity to select any value, there may be some restrictions. What are some restrictions that you've seen on different websites and different systems? Yeah.
Minimum characters or must contain letters, numbers.
Okay, minimum length of the password. Your password cannot be 4 characters. And it must contain a combination of characters, numbers, maybe at least one uppercase, maybe at least one special punctuation character. So some websites and some systems will have such rules. They can check against dictionaries. If your password is in a dictionary that an attacker may use, then they don't allow you to use that password. Okay, so the system controls the passwords you can select. They don't allow any choice. Let's say the attacker, it's me and I'm attacking, I'm trying to log in as many other students on the registration system. The system could then start to detect, okay, from the same source computer, there are attempts to log in at many different accounts. That's unlikely to occur. So the system can start to block computers that make multiple failed attempts. Okay, so if the website recognises this one web browser is making thousands of attempts on many different user accounts within a short period of time, then after some number of attempts, block that computer. So use a firewall, for example, to automatically set up a rule to disable that computer accessing the system. Problems with the countermeasures? What can go wrong? What about controlling password selection? What if I create a rule? Your password, it must be 12 characters long. It must have 3 uppercase, 3 numbers, 3 lowercase, and 3 punctuation characters. It cannot combine letters in this way. Then it makes it very hard for you to choose a nice password that you can remember and that you can type in. So if we control the selection too much, then the password becomes inconvenient and then users write them down, then they forget them. Okay, so you need a trade-off between having a little bit of control over what they can select, but having them some freedom so that they can select a password that's useful or easy for them to remember. What about blocking computers that make multiple attempts? What's wrong with that? Or how can it go wrong? Let's say Facebook blocks, if a computer makes 5 wrong attempts on any account to any Facebook account, then Facebook blocks and all subsequent requests from that one computer are blocked from accessing Facebook. What can go wrong in that case?
Somebody could misuse the
Someone could misuse it,
system.
change the IP. A more practical thing, it's more about the network structure, is that most networks use this concept of network address translation, NAT. What that means is when you access a website out on the internet, the IP address from the perspective of that website is the IP address of SIT. You check it one day, you go to a website like what's my IP address? And everyone will get the same IP address. The way that many networks are structured, that even though your computer internally has a different IP address, from the perspective of outside, they look like they all have that one SIT IP address. Therefore, from the Facebook web server, it doesn't know that it's a different person trying to log in. Okay, so things can go wrong if you do that. People can use fake addresses, people can take advantage of this, and it may not work in some network scenarios. Let's see if we can finish the next three. Password guessing against a single user. Again, you want to get access to my account on Moodle. So you gain knowledge about me. You're specifically attacking me, so you know me, and you try and guess my password. You don't have to do a brute force and try many passwords. Because you know me, then maybe there's a higher chance that you can guess my password. Okay? Maybe I mistakenly told you that I create my password based upon my birth year and my last name. Then since you know me and you know how I create my password, it's much easier for you to guess my password. Okay? And that's different to, let's say you want to just get access to any random user's account. Okay? If you know the user, you've got more chance as the attacker. Again, make sure the users don't choose easy to guess passwords, and train the users, educate them to use passwords which are strong. I'm logged in on my computer. I go to have a break 5 minutes outside. Someone sneaks up to my laptop and they can log in to my account. Okay? Computer hijacking. The simple example. That is, in computers that other people can get access to, then the password information or the login is currently valid for that computer, so that the user who accesses that computer is logged in as you. And it could be more complex using web attacks and so on, but the idea is that if you're using a computer that either multiple people access or an attacker could get physical access to, then you want to log out before you leave that computer. And websites and systems should have some form of automatic logout. If you go to a lab computer and access Facebook, and then tomorrow someone goes and accesses the same lab computer, they shouldn't be able to access your Facebook account. The system, the Facebook website, should automatically log you out after some time. Okay? So that's this general idea of computer hijacking. What else can go wrong? Users make mistakes. Because we force them to select complex passwords, they write them down on a piece of paper and they stick it on a post-it note on their monitor. Or they make mistakes and they tell their friend, "Oh, can you please log in for me? So here's my password." So their friend now learns their password. Or they're tricked into revealing a password. You call up the SIT computer centre and say, "Hi, I'm Dr. Steve and I want to, I forgot my password. Can you tell me my password?" And they tell you my password. Okay? So tricking people into telling you their password. Or don't change default passwords. You install some software on your website and that comes with a default password and you never change it. So the attacker can try that default password to try and log in. How do you fix it? Make sure users are smarter, provide them some training about how to use passwords and maybe combine passwords with other forms of authentication. And I think you know of some with mobile phones. You can use other factors for authenticating users, getting an SMS and so on. A big problem. Many users use passwords, the same password across different systems. I think we may have asked a couple of last week, who uses a password? Who reuses a password? Again, we'll try. Anyone has a password that's used on 2 different systems. Think of all the tens, maybe hundreds of websites that you have passwords for, all your accounts. I'm sure most people reuse passwords. What's the problem? If one of those systems is compromised and the attacker finds your password for that system, now all the other systems that use that same password are effectively compromised. Okay, so now it's the weakest point that leads to the failure. If just one of those websites that you've reused your password is compromised, effectively all of those websites from your perspective are compromised. The attacker has your password for all those other websites. All right, there's complexity of how do they know which other websites you visit, but I think they could learn that in many cases, or try. So this is a major problem because that suggests we should use different passwords across different sites. But who can remember 100 different passwords? Okay, so that suggests we need some other way to manage passwords. And in many cases, things like password managers, software that will keep track of your passwords for different systems is one way to get around that. How can you stop this? How do you stop a user from reusing a password? Well, you cannot in a public system, but say SIT could, of all the services that SIT uses, registration, Moodle, and others, because they're separate services but all under control of SIT, we could set up a system that forces you to use different passwords across each. It would be hard to do, but it's possible. Final. The other way that attackers find passwords is by intercepting the packets which contain them sent across a public network. I visit a website on my laptop and I log into that website. My computer, my laptop is sending wirelessly to that access point, which then goes across the LAN and then out to the internet. It'd be very easy for any of you with your laptop to intercept and take a copy of the packets my laptop sends to the access point. And hence, in those packets, one of them will contain my username and password. Basically, the only way to stop it is to encrypt those communications. Make sure that where people can intercept, anything that is sent that contains a password is encrypted first. How do you do that? What techniques used normally in the internet? When you log into Facebook, how come no one can intercept your password? HTTPS. Okay, when you visit the website, many websites, not all, but some will, at least when you log in and submit the username and password, they'll be using HTTPS, which it means that the communications between your browser and the web server in the US are encrypted. So even if someone intercepts, they'll just see some random characters. They will not see my actual password. What's the problem with that? What's the problem with encrypting? It's what? Yeah, it's easy for the user, but it's slow for sometimes the computers, especially the server, and maybe it slows down the communication. So performance is the problem. Okay, so if the web server has to handle many encrypted connections, encryption takes some time and it slows down the server. Yep, performance. I think most of them you may have heard of before, but we just try and put them down as common problems with passwords. You may get a question in the exam about them, or similar issues with passwords. Any questions? That was one thing that we missed in the earlier lectures. Any questions on those vulnerabilities of passwords? Password entropy, how do you calculate it? Calculate the password entropy. Guaranteed question in the exam. How are you going to do it? Again, log base 2 of what? Of the number of possible passwords. Okay, so if a password selection scheme allows you to have 1 billion different possible combinations, then we say the entropy of that, or a password using that selection scheme, is log base 2 of 1 billion. Okay. Have a look at the lecture notes on which we've covered already on password entropy. A quick test then. If a password, so look at that slide, if a password was made up of, let's say, a random password, but made up, it had to have 2 digits, it had to contain 2 English characters, lowercase. They must be 2 lowercase English characters, and maybe any 2 of the 94 characters on the keyboard. I'll say 2 printable characters. What's the entropy of that password? Try and calculate. If you can do that, you'll be on track for the exam. So the password is 6 characters long. 2 of the characters must be numbers. Any numbers, they're random. 2 of them must be lowercase English letters, and 2 of them must be any of those 94 printable characters on your keyboard. Uppercase, lowercase, numbers, punctuation. What's the entropy of that password? So entropy. Anyone have an answer? Think about from the sets of characters. And as a hint, you can look at the individual characters. Or you can go the long way. Remember, entropy of the password is the log base 2 of all possible combinations. Anyone have an approximate answer? While you're calculating, I'll just record what we know. Digits, we have 10 possible values. Lowercase, we have 26. Printable characters is a total of 94 possible values. We're assuming that here. That is lowercase, uppercase, numbers, plus the 32 punctuation characters. Entropy? Well, let's look. Just go back to our slides here. We said the entropy of a single digit, 0 to 10, is 3.32. Where does that come from? Well, with 10 possible values, log base 2 of 10 is 3.32. So the entropy of one digit is 3.32. The entropy of a lowercase character is 4.7. And the entropy of, so log base 2 of 26, entropy of the 94 printable characters is 6.55. Log base 2 of 94. Just make note of the entropy of them that we have. This was 4.7, I can remember. That's the entropy of one character of that type. If you do the maths, you see, remember we're using log. So in fact, because we have 2 digits, the entropy of a 2-digit number is what? Well, we have 100 possible values, 10 times 10. Log base 2 of 100 is what? Calculator? About? 6.64. 2 times 3.32. The log of 100 is 2 times the log of 10, because 100 is 10 squared. So in fact, with 2 digits, each having an entropy of 3.32, and then 2 lowercase letters having an entropy of 4.7, and another 2 printable characters with an entropy of 6.55, that gives us the total entropy of this 6-character password, which is whatever it is, about 27. You can get it more accurate. That's the beauty of entropy. You can add them up for individual characters because it's a log-based measure. What's easier, adding or multiplying? Adding's easier. That's why we use logs sometimes. You could have done it, calculated the long way. You could have said, okay, there are 2 digits, there's 100 possible values, or 10 times 10 possible values. 26 here, so 10 times 10 times 26 times 26 times 94 times 94, and take log base 2 of that large number, and you should get about 27. So if we know the entropy of an individual character, if we just increase the length, we can easily calculate the entropy of the whole password. I just 26, I approximated. I think if you calculate with a calculator, you'll get closer to 29. Okay. My adding is not as good as a calculator. Any questions on entropy? If you wanted to do it the long way, it would be log base 2 of first a digit of 10 characters by another 10 digits, 26 for the 2 English lowercase letters, and 94 times 94. If you calculate that, I think you also get 29, or approximately 29. It's the same math, just calculated differently. How do you store passwords? Put it into a database. Okay, he won't get full marks in the exam. Anyone else? How are you going to store a password in the exam? If a question says, how do you store a password? Hash them, you'll get wrong, 0 marks. Hash them.
As plain text and in a file called passwords.txt.
Hash the...
No, just put them as plain text there and call the file.
Yeah, okay, hide them. Hide them. No, 0 marks.
Salt the password.
Salt the password, then hash. Generally called a salted password, or a salted hash, a salted password. And we sort of ran out of time to go through the detailed explanations, especially rainbow tables. I went through that quite quick last lecture. I will not ask a question about rainbow tables in the exam. What's the problem with just storing the password in the clear? Well, if the system's compromised, someone's immediately learned all the passwords. So we can't do that. We could encrypt. Okay, it's possible. We saw a possible way last week. There are a few issues with encryption, especially if we use the same key to encrypt all passwords. We need to store the key somewhere. So it's possible, but usually it's no better than using a hash. And usually we need to use a hash even if we encrypt anyway. Because if you encrypt, sometimes it's hard to know whether it successfully decrypts or not, especially if you encrypt random passwords. We said we could hash the password, but there are some problems in that it's possible that people can do a lookup on this concept of a rainbow table. What you should remember, if you don't know about rainbow tables and all this that we went through last week, remember how we recommended to store the passwords. You store the username or the ID. A salt. What is a salt? Random value, different for every user. Okay, so a random value, it's just called a salt here, and we hash the password combined with the salt. I don't care how they're combined. Password salt, salt password, but they're combined. Okay. So we store a hash value, the random value, and the username. And when someone submits their password and username, we look up, find the username, we take the submitted password, combine it with the stored salt, hash, and compare to the hash value. If they're the same, they log in. If not, failed attempt. It would be nice to talk more about rainbow tables and why this is needed versus just a hash password, but unfortunately we're out of time, so there won't be a question about rainbow tables in the exam next week. There may be a question about how to store the recommended way. Okay? So remember that. All right, more specifically, which hash function do you use? There are some recommended hash functions for making it harder for the attacker, but we didn't get to cover that. We designed for failure. It would be nice if no one could ever access the database. No one who doesn't have authorization, if not, they couldn't access it. Doesn't matter how we store the passwords. But designing for failure is saying, okay, assume something can go wrong and an attacker can access the database, then let's design such that it's still hard for them to get the passwords. And we, in our first discussion of this topic, we gave a few examples of how people choose passwords, and I think you gave me a few written down password selection strategies and some common ones. And to summarise and finish this topic, all right, to make sure that people use passwords well and select good passwords, people need to be aware, the users need to be aware of how important the passwords are and how easy it is for an attacker to guess some forms of passwords. Computer-generated passwords sometimes are useful. The computer generates a password for you. The user doesn't get to choose. More secure, but can be more inconvenient because you get some strange-looking password that you have to remember. I think everyone, when they first got an account on Moodle, got an email with this random password computer-generated. I suspect if you haven't changed it, then you've got that email and you go always look it up. You haven't remembered it. Okay, that's the problem. You can have variations where it's generated is pseudo-random, but it's maybe pronounceable. Okay, you combine the letters in a way such that it's a little bit easier to actually say it. And if something's pronounceable, it's a little bit easier to remember. Okay, so you don't generate a password which is QTXZB. Maybe you generate a password which is not a real word, but has the correct arrangement of consonants and vowels, so someone can remember it easier. Reactive password checking. If the users of your system have selected their passwords, you could go through and check and see if they're easy to break, and then advise them to change their password. Or check as they're selecting the password, and many websites do this. You type in a password, it shows you some graphical feedback saying this is weak or this is strong, or it even may say, sorry, you can't use that password, it's too weak. Okay, so some advice on selecting passwords.